Good morning everyone, I am Mr. Ish. Thank you for joining me for this video. By a special request, we are showing you here the area of a regular rhombus, the integral calculus derivation of that area formula. I have the area formulas here for you, half P times Q or half D1 times D2, where P and Q represent the diagonals, D1 and D2 represent the diagonals. You can see the diagonals. You know, for a regular rhombus, either of those formulas, area formulas, is good. A regular rhombus is a polygon with 4 equal sides. You have one diagonal, the other diagonal, two acute angles which are equal to each other, two obtuse angles that are equal to each other. How can you go about determining the area? Well, what you can do is make a representation such as this. You're developing two axes, x and a y axis, and you can rotate them mentally in your head so that you can then represent your rhombus in the following way. Remember, I'm not drawing things to scale, but that would represent a rhombus. One of these axes could be the x, the other one can be your y axis. Then suddenly you've developed 4 points, and we have to identify those 4 points. If this here represents one diagonal, we'll call this diagonal Q. Then we're looking here at that Q. This becomes 0 comma Q over 2 because we've cut it into halves. Here's one half, here's the other half. This becomes 0 comma minus Q over 2. If this here represents the other diagonal, we'll call this diagonal P. Then again we're splitting it into 2's, minus P over 2 comma 0 and P over 2 comma 0. What you can do for your procedure, and to simplify it, is you only look here at this top part right here and you multiply everything in the end, or during your procedure by 2. You can essentially eliminate everything here. Then obviously you have to look here at a right boundary curve and you have to look here at a left boundary curve, and your integral procedure is the difference of those two. When you look at this line over here, the slope is minus Q or P. You have two coordinate pairs, you can easily determine the slope. Your equation y is equal to minus Q over Px plus y-intercept Q over 2. You have to write everything here in the form x is equal to y minus Q over 2 divided by minus Q over P. But you can hit everything with this minus and you can say x, or your right boundary curve, is equal to Q over 2 minus y divided by Q over P. That right here is your right boundary curve. Your left boundary curve, since everything here is symmetric around the y-axis, is easy. It'll be the opposite of that, y minus Q over 2 divided by Q over P, because here the slope of this is going to be positive Q over P. I've given you your right and your left boundary curves are easy. You could have determined them for yourself, and in each case you solve for x, because your equation has to be in the form x equals. So let's develop our area integral. Area with respect to y is equal to, I'm bringing in the 2 right now, 2. You see this times 2, I'm bringing it here, 0 up to this height right here. Q over 2, your right boundary curve which you have over there, Q over 2 minus y divided by Q over P, minus your left boundary curve, I have y minus Q over 2 divided by Q over P dy. You have a common denominator, push it out, you'll have a 2 over Q over P, 0 Q over 2. Q over 2 minus Q over 2 is a positive 2Q over 2, which is just a Q. Think about it, a half minus half is a half plus half, which is a full. Minus y is a minus 2y dy. Integrate this. Now flip this fraction around. 2 divided by Q over P is a 2P over Q. Your antiderivative with respect to y, Qy minus, from here it's easy, you know what the antiderivative is, n plus 1 divided by n plus 1. The 2's will cancel out, you just have a minus y square. You're looking here from Q over 2, 0. Don't put 0, 0 is meaningless. You're putting Q over 2. 2P over Q times Q over 2 is a Q square over 2 minus Q square over 4. This square is going to impact the denominator too. Over here you're going to get a 2Q square minus Q square, which is a Q square over 4, which is multiplying with a 2P over Q. You have nothing more other than simplification and cancellation. Q cancels out with this, 2 cancel out with this. You'll have a P times Q over 2, and here is your area formula. If you were using D1 and D2, your formula would be D1 times D2 over 2, and your answer would be right. Your area formula for a regular rhombus, either of these is great. And I've shown you how you do it. Mentally, you started out with that rhombus, but you rotated it in your head, so you can put it on an x and y axis in a more friendly manner, so then you can start plucking out these points. This entire is one diagonal Q, then you bring in the halves because you're separating it. This entire is your diagonal P, then you're separating into two halves, hence you're getting these fractions here. But you work with those fractions, you develop your right and your left boundary curves, their difference, the integral procedure all the way through. times it by 2 because we're looking here at only 1/2 of a rhombus. You multiply by 2 and you get your answer, and that's what I'm showing you here in this video. Have a great day. Bye.